and how to find all its other angles, and then after that then we look at the quadratic equations. Okay, so having done that, I think then we should be set for these kind of things. So let's start. So we're going to say tan. So tan 3x is equals to minus 1. So what are we going to do then? So like we were doing yesterday, so then we are using the interval. Okay, so here when you look at that particular question, you want to start asking yourself to say, in which, since we are using this range, so you ask yourself, in which quadrant is what is tan negative? So you start asking yourself, say, okay, so it's going to be where? It's going to be in the second and the fourth quadrant. Then you say, what is the acute angle that gives 1 for tan? And you realize that the acute angle that gives that it's going to be what? That's 45, right? It's going to be 45 degrees, isn't it? So but 45 degrees, remember, 45 degrees, but we are using radians, but 45 degrees in radians, we know it's what? It's pi over 4. Now, this is not our answer. Why isn't this not our answer? Because we know that this is an acute angle. Because we know that tan, 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 when tan 45, right? Tan 45 is equals to 1. So it's an acute angle. Now, we know that what the angles we are looking for is not an acute angle, because this would have been true if the answer we're looking, if this was positive. Because then we know that their tan in the first quadrant, where 44 degrees is, tan would have been what? Tan would have been positive. Now it's negative, so meaning we have to find answers for these which are where? Which are in the second quadrants. Okay, that are in the second quadrant. So how do we find angles in the second quadrant? We say x, then we are going to say okay, let's use theta, so that yeah, like we were doing yesterday. So let's take theta, so that when we start doing the conversions, you won't have any confusions there. So what we are going to have, we are going to say 180. Okay, why am I using 180? So I'm going to say pi that over 4. You are going to have what? You are going to have 3 pi over 4, which in degrees is going to be what? 135 degrees, isn't it? And this is in the second quadrant, so meaning that this is an answer. Okay, then we now go now for the fourth quadrant. Our answer, how do you find an angle in the fourth quadrant? What do? You subtract your angle, your acute angle, from what? From 2 pi, which is from 360, right? So what we are going to have when you subtract 45 from 360 is what? Is 315. But in radians is going to be what? 7 pi over 4. Okay, so then you have your answers like that. So then what you then want to start doing is then to say, remember, so then what we start doing then, now this is where I wanted to do this question. So we know that 3x, we want now to solve for x, right? So we are going to get what answer? The answers that we found, right? So we are going to get this 3 pi over 4. Then to find the other angles. That's where that's why specifically I wanted us to do this example. Because to find for the other angles, remember for the cos and the sin and the sine we're doing 2 pi n, right? But for this one, we do pi n. You've gotten the point, right? I hope you've gotten the point there. So, and if you want to be remembering this, remember that the period for tan is what? Is pi. You can remember it like that, whereby for cos, for sine and cos, it's 2 pi. So that could be a reason maybe why we say pi n and 2 pi n, right? So that could be a way for you to remember those things, right? So having done that, and then one thing you may want to realize is that, you see, if we get this again, we also want to write this as 3 pi 4, then this is going to be pi n. Now you will realize that if we put 1 for n here, we are going to get what? We are going to get 7 pi over 4. So this simply means that from this same expression, which this one which we've written, we can be able to get this answer. And because once we start adding, then n to be 2, meaning that we can get practically all the answers using just this one expression. But remember, this may not be true always, so you may want to verify that fact. Okay. Okay, great. So once we've done this, then remember now that all this that we are finding was 3x. Okay, so now we want to now find what x is. So you multiply everything by what? By 1 over 3, or divide by 3. It's the same thing, right? So then what's going to happen is, so what then is going to happen is, so you're going to have, so you cancel that. Okay, so then that's what then. So now those are the values of x that we are looking at. Okay, so meaning now when we start answering for our values of n, so we start for our values of x. So our values of x, I'm going to be writing them here. So we start with n when n is 0. When n is 0, x is going to be what? Pi over 4, isn't it? So that's pi over 4. Then let's now get the second one. So then what we are going to do now, it's when we put, so then when we now want to get this now, we're going to say pi 4, then this is going to be pi 3, there we've put now 1, isn't it? So 1 there is going to be, the denominator is going to be 12, isn't it? So here the denominator is going to be 12, then here it's going to be 3 pi, then there is going to be 4 pi. So we see there we are going to have our second answer being 7 pi. And now you always have to be checking whether these answers are what? Whether these answers are falling in your what? They are falling in your range. Because one thing that you don't want to do, is to get an answer which is above your what? Which is above the range which you've been given. But for now, we are looking at the range what? From 0 to 2 pi. So to look at this, so you just look at the coefficient. Is this 7 over 2? Is it greater than 2? No. So meaning that's within. Or converting that to degrees, you will see that it's below 360 degrees, because that's just 105 degrees. So then now you can now proceed just to do the same. So when n is 2 again, you are going to do the same. You are going to have the same way we did it. Maybe someone would want to see us do it, but anyway. So it's going to be pi 4. Then you are making this what? N to be 2, isn't it? N to be 2. So that's going to be that pi over 4. Then you're going to have 2 pi over 3. Then you've got 12. Then 12. Then you've got 3 pi. Then you've got 4 pi. That's 8 pi, right? So you add the 8 pi plus 3 pi. What are you getting? 11 pi, right? Okay. Then if we continue, so by the same token, now if we want to continue, let's see now the next one is going to be what? The next one is going to be, if now n is 3. If n is equal to 3, we are going to have 15. So we are getting what? We are getting 15 over 12. And if we want, we can actually reduce this. We put 3 there. So 3 is that's going to be 5 pi. And that's going to be uh, 4 pi, isn't it? So we see that we can reduce that. Again, we go next, we just move the n again. We are going to have what? Again, we are going to have 19 pi over 12. Again, we continue. So the same procedure that we've been doing it. Okay, so that. Then when we continue, so now if we continue, we are going to have 27 pi over 12. So now you see this one, this is going, the 12 is going into 27 more than 2 times, so meaning that it's more than pi, isn't it? Or if you can want, you can convert it to your radians or to your degrees. It's going to be what? It's going to be 405 degrees, right? But the 23 over 12, that's what? 23 over 12, that's 345 degrees. So meaning that you end your solutions where? From here. Okay? So you end here. So these are going to be your answers. Remember this one that I've written just down, it's just a simplification. So now, uh, so that's the key thing. Okay. So pretty much that's how we solve these equations. Okay. So that's how we solve these equations. So that's something that I just wanted us to appreciate on that aspect. Okay. So having done this, then we can now go to the actual thing for our lesson today. It's solving these kinds of questions. These ones. So you are solving sine x squared plus 2 sine x. So there, now solve for x, right? Interesting, I love this. So now if you want, looking at it like this is can be tricky. So what you do is you say y is sine x. So you say, or if you want, you can just make this on somewhere. So okay, some lecturers, if you want, you can do it from there. But yeah, you can do it whichever way you want to do. Either you can write this separately, then you just start using the sign, but it's usually non-consequent. It's you can do any. There's really no hard line way of doing it, right? So we did how to solve these things. So you are looking for something which you can multiply the product to be -3, then the sum is going to be what? It's going to be 2. So those numbers are -1 and +3, right? So that's that. So what numbers? So when you factor, you're going to have that y, then you're going to have that. Okay, so that's that. Okay, so at this point, if you want, or rather, you could then replace sin x -1 sin x, that, right? Then you're then going to break uh, these two and say, and you're equating them to 0, right? Oh, sorry, I went a little bit ahead of myself. 1, then for this other side, now this does not exist because we know that the function, we know because the function of sine does not go all the way to -3. It just oscillates between what? Between 1 and positive, between +1 and -1. So this, there's no way. If you want on your calculator, try it. Say the inverse of negative sine inverse of -3. It says math error. Okay, so that is not a solution. So you just begin to focus on this other one. So this is going to be x, which is going to give you 1. It's going to be that's that, right? Isn't it? It's, yeah, it's going to be 90 degrees, right? So it depends. I don't know, but I want to be using radians so that people can get used to radians. So, or that's that, or if you want in degrees, that's 90 degrees. So now we know that this is positive, right? And where is sign positive? All students take coffee. So it's positive in the first quadrant where 90, yeah, pretty much is, but it's on the middle, right? Now, what do we do to find the other one in the second quadrant? We say what? It's 180 minus 90. So you see, it's basically the same thing, right? So that's why we are just going to find one answer. Yes. No, it's not dependent on which method you want to use. They are going to specify. So, like for this one, they would say something like for where theta. So they would say where theta. So meaning, yeah. So they always. I'm sure when you check your trigonometry questions, there are always things like that. Or sometimes they will say where x is 2 pi. So yeah, so based on just these, you will know whether your answers should be in degrees or they should be in radians. So they will always specify. Okay. Yeah, so they always specify. Yeah, but that's a very good question. That's a very good question. But they'll always specify. They always specify. They always specify. So yeah, so having done that, we can now go to the next question. So yeah, so you see, with the way that we've built through this topic, you've seen that answering. Wait, did I say the answer was pi over? Did I say pi over two or pi over four? I said pi over two, right? Okay, yeah, but that should be pi over two. But okay, yeah, okay, great, okay. I thought as though I said pi over four, so I just thought I should correct that. So let's now look at something in terms of cos. So here you are doing the same thing. If you want, you can say. So if you want, you would say. So the product is going to be what? Negative 6. Then your sum is negative 1. So which two numbers can do this? It's negative 3 and positive 2, right? When you multiply them, they give you negative 6. When you add them, they give you negative 1. So there we now have it. So then we are now going to uh, factorize. So if you want again on the factorizing part, if you don't want to substitute, if you don't want to use the substitution, if you want, you can just go direct. But doing this will make your work easier anyway. But in case your lecturer wants you to show the working, you can just go by this route as well. It's going to be the same concept. So you are going to say then positive 2 cos. So there. Okay, so then again the factoring is going to be the same. So you see things in the brackets are the same, so that means we are correct in our factorization. So we're now setting each factor equal to 0, right? So then from here then we are going to say cosine that. So I would want someone to tell me whether this exists, whether this exists. Does this exist? It does. Okay, so the one that says it does, kindly tell us why you are saying it does, and then the one that said it doesn't exist, tell us why you say it exists. So the one that said it does exist, tell us why you say it exists. Okay, yeah. So it doesn't exist, so there's nothing you can do. Then, yeah, so now let's go to this. This one cos x negative 1 is going to be what? x is equals to what? To pi, or x is equals to 180 degrees, right? When you do cos 180 degrees, you are getting that. Yeah, so you are getting that. So then how then would you then be able to, so you know that this is where is cos, why is this having difficulties? Okay, yeah, where is cos negative? Cos is negative, so all students take coffee. So it's going to be negative where? In the third and the second quadrant. So then, yeah, so so when you look at where 180 is, it's quite a tricky one to put, because first of all, what you're going to see is that if you say, let's do it like this, because if you say, basically it's going to be here, right? 180 is here, and it's in between, so that's why you can't really find anything which can be between here and between that, right? So basically this kind of equation is going to have one answer, okay, so which is just pi, like that. Okay, so there. Okay, so 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 let's now look at this equation. So the way you can deal with this question, if you want, you could say, let's say, maybe you say 4 sines that, then you say 4, then you're going to have sine squared, then 1 over 4, then square root. Now remember, whenever you take a square root of something, you are going to have a plus or minus what? Plus or minus half, isn't it? So meaning what you are going to do is, you are going to have that, and then you have to solve. So meaning you're going to have how many answers? 4 answers. Why are you going to have 4 answers? Because uh, remember we are using our from 0 to 360 degrees, right, to be our range. So it means all students take coffee. So you see that sign is going to be positive in the first and quadrant, in the first and second quadrant, and then since there's also the negative one, it's also going to be negative in here. So you see that for this one, you're going to have 2 answers. For the one on the left and the other one on the right, you're going to have 2 answers as well. Alright? So now, so we're just going to leave it there, and there's just a certain thing that I want uh, to show us. Okay, so uh, okay, so now that's about it. Then now we can now be able to build. Now there's another way in which you can find this. You can use the difference of two squares. So how can you use the difference of two squares? So don't worry, we'll finish this, but I just want us to have different perspectives of really being able to answer such kinds of questions. So you're going to have that. So difference of two squares is going to be a plus b, a minus b. Then what you're going to do is, so basically for that one, you're going to say it's basically like that. So you're going to say 2, so you use the square root of that and that. So it's going to be 2 sine x Oh, sorry, I've made a mistake. I left a negative 1 here. Okay, so it's going to be a what? So square root of 4 is what? Is 2. Then square root of sine, yeah, then square root of sine, thank you very much. Then square root of sine squared is going to be sine x. Then here we put a positive. Then here, of course, we are going to put a difference of two squares, which is going to be a minus. So now, so then, uh, so having done this, so you see that basically we are going to get the same situation that we got in the earlier question, right? So I just thought it's, it's always good when you've got different ways of approaching something. You never know when it may be easier to use either of the two. So that's that. So you see that it's basically the same thing, right? So now we are going to find the angles from where we left the first part. So that, then here it's going to be uh, that, then it's going to be that, then it's going to be that. So we are not yet done. Now let's find those angles. So can someone tell us what sine sine? Okay, let's start with the positive one. The positive one is usually the, the easier one. So sine half, sine 0.5, what's going to be x? People, these things have to be on your fingertips by now. Hmm? It's what? It's 30 degrees. Okay, so x is going to be 30 degrees. So all students take coffee. All students take coffee. So we found that. Then to find the one in the second quadrant, you say 180 minus 30 degrees. So you're going to have what? 150 degrees. So that's your answer, isn't it? So that's pretty much your answer. So then we now go on to now check for those where we're going to have negatives. So it's just basically going to be those which are going to be in the third and the fourth quadrant. So how do we find an angle in the third quadrant? We just get that plus the angle that we found to be the acute angle. So it's just 180 plus the acute angle that we found 30. So it's going to be 200 and what? 210. Okay, so it's going to be 210. Okay, then how do you find an angle that's in the x-axis? So hey, what am I saying? In the fourth quadrant, you say 360. Oh yeah, so three, yeah, thank you. Great, so that's 330. So that's going to be 330, right? So so having found those, so those are going to be our what? So those are going to be our angles for this particular question. So you see, that's really how you go about this question. So, but I just wanted to show you two ways of doing it so that you can at least have a different array, perspective rather of going about these questions. Okay, let's now look at cosec. So if you've got cosec squared, cosec x, cosec squared minus 2 is equal to 0. So if you want here, you could use the difference of squares. Uh, but like I said, these things, it's not about just using it because it's usable, but you always want to see if it's going to be easy. So you see, you can use this if you want. and you're going to get your answers. Yeah, you are going to get your answers because square root, mm, you're going to get that, right? So, but oh no, no, sorry. One should be positive. Sorry, pardon me. Yeah. So, yeah. So you can find it like that. But this one is really more straightforward, really, when you just treat it the way it is, right? But if you want, you can do it that way. But I feel for this one, it's a little bit more straightforward. So that's something that I would like to make mention of. So again, it's not about memorizing. So why am I forgetting the x? Why am I forgetting the x? Okay. Okay. So cosec going to be 2. Then that and that is going to be cosec x. Now here is where many people miss it because they're only going to think of it as it only having one answer, but in the actual sense, there is actually plus or minus -2. So please don't make such a mistake of forgetting that. Now, just leave looking at cosec like that, there's pretty much nothing much you would do. So what then you want to look at is to look at cosec for what its identity is. So its identity for cosec is what? Remember we said you go for the third letter, right? So third letter is S. So it's 1 over sine. Okay? It's 1 over sine x. So what you're going to do here, you're going to say, so it's 1 over sine x, and then plus or minus. Don't worry, we're going to separate these two so that it will be easier. So then what we now do is, um, okay, so then what we are going to do then is uh, pretty much like you cross multiply now, right? So yeah, so you're going to have 1 sin x, then you're going to have plus or minus that, then of course you do it like that. Of course, this is just me trying to show you showing all the processes, but anyway, that's that. Then you're going to have ish, what am I writing? The plus or minus have to be outside the square root. Yeah. Okay, so plus or minus 2. So you cancel that, then what you're going to have is, I didn't just want to just do it directly because I always want to ensure that we are always at the same page with everyone. So plus or minus 1 over half. So again, remember you never leave a side in this. You always want to rationalize it so that the denominator is not a side, right? Especially in that context. Remember when we did sides. So what we are going to have is uh, sine x. So then we are going to have plus or minus pi 2 over 2. So then what we are going to have is, then now separate and say plus. So can someone give us what the value of x for this is first, and then also hello. So okay, so that's 45, right? Great. So 45 degrees. So this is where cos is cos sorry, sine is positive. So all students take coffee. So to find the other thing which is positive, another angle which is positive for sine, it has to be where? It has to be in the, so we've already found it in the first quadrant, so it has to be in the second quadrant. How do you find it? You say 180 minus 45. So 180 minus 45 is what? It's 135. Okay, I hope everyone is comfortable with that. Uh, then we now just start finding now the answers for things which are going to be in the parts where it's going to be what? Where it's going to be negative. So you're just basically looking at those angles which are where? Which are in the third and fourth quadrant, where you're going to have uh, so you say 180 plus the acute angle 45. So you're going to get 225. Then you're going to get 360 minus 45 degrees. So you're going to get what? Um, 315, right? So you're going to get 315. So really, so you see, it's just about those concepts, right? So they just basically just build up on the same concepts, and then you should be able. Okay, sorry about that. Then you should be able to just do all right. Okay. So having done that, we can look at the other things. Okay. So then we can look at the other things. So let's look at okay. So how do you answer this question? Now, this question, remember, there was one time where I said the reason why we were going through the procedure of first doing the identities before we could start the equations. It's because there are certain equations, and you see the ones that we start doing, where for you to answer them, you have to use uh what's the term? You have to use identities, right? So you have to use certain identities. So that's why I first wanted us to do the identities. So here, what identities are you going to use? Okay, so you're going to use the double angle, isn't it? Isn't it? So here you're going to say, now the temptation that most people have here, it's where they want to divide both sides by cos. Now when you divide both sides by cos, you may lose an answer. Okay, you may lose an answer. So please don't go for that temptation of wanting to say this over that and that over that. Don't go for that temptation. You are going to lose an answer, okay? So you may find yourself getting half mark or half marks. So what you do is you bring this cos x this side. Okay? Then now you can factor. So it's cosine, which is common. So you see that had you uh, done that division, you would have lost the what? The cos x is equal to 0. Then you can also say 2 sine x minus 1. So you're going to have that. over that. So you're going to have sine x. So now again, what is that angle going to be? Sine x. Let's do the sine x first. So it's going to be 30, isn't it? It's going to be 30. So it's going to be 30 degrees. So we know all students take coffee. So sine is going to be positive in the first quadrant and then also in the second quadrant. I've just written 150 because we know how to find the angle, right? So in the second quadrant. So yeah, that's how we are coming about that one. So that's basically how you do it. So we are done with this. Let's now look at cos 0. So what gives us cos 0? What value of x gives you cos 0? So you realize that it's what? It's going to be 90 degrees. Then you're asking yourself to say, is it only going to be 90 degrees that can give you this within the the range of 0 to 360 degrees? So here what you are looking at, just to put things in context, you know that tan tan x is cos to what? Is cos to sine x over cos x. So you know that where cos x is 0, that's where tan has got the asymptotes, isn't it? So you remember that equation that I gave you for determining the for determining the asymptotes of tan. You basically use that equation, right? So that's about it. But anyway, since we looked at it, I'll just put the answer since we discussed it, and I know that you still remember. So in this, what you're only going to have those answers, okay? Within that aspect, or within that range of 0 to what? Of 0 to 6. Okay, so I don't know if there are any questions before we can look at something else. Okay, so if there are no questions, what then? Yes, that's cos x is, that's the degree where cos x is 0. You remember those graphs? Yeah, and that's where I was been saying that the other way you can remember it is where tan has got vertical asymptotes, because where tan has got vertical asymptotes, it's those points where cos is what? Where cos is 0, where cos x is 0, where cos x is 0. Because if cos x is equal to 0, then this becomes undefined. So that's where tan, and I gave us a formula when we are sketching the tan graphs. So there is a reason why I really planned out that we move in that particular fashion, because I knew that you'd have to make use of the graphs for you to be able to answer these things properly. So yeah, that's that. So then, so now, so now with these particular questions, you see that we've got two different, we've got a sine and the cos. So many people wonder which one do we have to replace. So you have to look at with the one that is alone, the one that's not squared. So you want to change the one which is squared, to change it into, you know, of course it's still going to have a square, but you want it to have a square in terms of side x. So what identity do you use? You use this identity. And let me not write here. Let me write here. So you're going to have that. So then what you're going to do is, so you're going to substitute there. So let's expand this. Okay, so you're going to have, okay, so you're asking yourself, what two numbers can you multiply to give you uh, positive 4, and then you add them to give you 4. So that's going to be what? That's going to be 2 and 2, right? Positive 2, 2, right? So we're going to do that. So here we're going to do, if we want, we can put negative. So we do that. Sorry, pardon me. Okay, yeah. Okay, so there you're going to have that minus 1. Then here there's nothing that we can factor, so we just use a 1. So you see those two things in those brackets are the same, so we are in good shape. So we have that. Okay, so we've got negative and then that, then we've got that and that. Okay, so what we are going to have is, let's equate this. So that's negative 1. So I know we're almost about run of time, but let's just finish this. So let's do the other part as well. So the other part is going to be, rushing. Okay, yeah, so okay, yeah. So then we are going to have, I realized that I was rushing, so I was making a mistake in writing. So you see that these two things are the same, right? So that means that the answers that we find for one are going to be the same for both, right? So we know this is going to be what? 30 degrees. So you see, by practicing so many questions, you see that you're going to get you like that's the best way you revise these perfect angles. It's just by basically revising them. Okay, the more you revise them, the better they are. They will be on your fingertips. So that's really pretty much about it. So yeah, this was something that was more of a perfect square. So that's pretty much about it. So we're only remaining with a few questions that will, I think maybe about two or three more. So I think those are the questions that we'll be able to go through tomorrow, and then we should be able to start limits most likely tomorrow. So at least we can do maybe two or yeah, at least two more examples. So at least we can look at various aspects of these things.